Welcome to In 5 Minutes. Now we are discussing next category of operators, that is bitwise operators in C. Now to understand these bitwise operators, we have to know what is binary numbering system, what is relation of binary numbers and decimal numbers, that is normal numbering system that we use in mathematics, and we have to know how numbers are stored in the form of ones and zeros in computer. Now this topic is very difficult to understand if you go into deep, but we have to understand this topic from our subject point of view. That is just an introduction of how the bitwise operators work and how the values are evaluated finally. You can refer to the previous video in which we have just discussed what are the binary numbers are and what is the relation between binary numbers and decimal numbers. Now 2 points we have to remember regarding bitwise operators. That is, first is these operators work with the bits of the operands. That is, if the operand value is 5, will not consider that value as a 5, will consider its bit pattern, that is 101. Suppose the number is, or the variable has value 13, will not consider the value as a value 13 as an integer value. Instead will consider its value as a binary equivalent, that is 1101, and using those bit pattern, using those bit values, that is binary values, will evaluate the answer. The second point is, you remember that they are applicable for integer values only. We cannot operate bitwise operators with floating point values, so they are applicable for any kind of integer values. Now there are two broad categories of bitwise operators. First is bitwise shift operators. These operators do the shifting of bits in the given number on left side or right side, and accordingly there are two kind of operators. One is left shift operator, written as less than symbol twice, and right shift operator is written as 2 greater than symbols. These operators shift the bits of the operands, that is values, on the left side or right side according to the way we write it. Second category is bitwise logical operators. These are the logical operators, but they work with the ones and zeros, assuming 1 as true and 0 as false. They work with the binary values of the given operands and generate the answers again as ones and zeros. Obviously, finally we consider the entire value as an integer value only. Now that demonstration will understand with the following video. So there are 4 categories of operators over here. First is AND operator, written as single ampersand symbol. Then is OR operator, written as single bar symbol. XOR operator, it is called as exclusive OR operator, that is written as circumflex, that is a symbol above your 6-digit key. And complement operator, it is called as tilde operator, it is just below the escape button. So these are the 6 operands we are going to study. Let's start with the first category, that is bitwise shift operators. Now assume 3 values, A is 12, B is 2 and C no value. Now what kind of variables they are, that will not assume, only assume that there are 3 integer variables or there are 3 integer values. The first operator is bitwise left shift operator. Now according to the name suggests, the bits of the operand will be shifted on the left side by given number of positions. Now here the statement is read like this. It is C equal to A left shift B. Now A is 12 and B is 2. Bits of A are shifted on left side by B number of positions. That is, bits of A variable will be shifted twice on the left side because B is 2. If B was 0, there won't be any shifting. If B was 5, the bits in A will be shifted on left side by 5 locations. Now let's draw the bit pattern of A and B, assuming they are 8-bit variables. So since A is 12, it will be 1100. So there will be 1100 and left side bits will be all zeros. Now when you shift the bits of A on the left side by 2 positions, the resultant value will be stored into C. A will be unaffected. So A will remain as it is. The pattern after shifting the bits of A on the left side by 2 positions will be stored into C. So after shifting, this will be shifted twice on the left side. So this 0 will be placed over here, this 0 placed over here, then 1, then 1, then 0, then 0. So it's somewhat like this is shifted over here, then next 0 shifted over here, then 1 shifted over here, then 1, then 0, and then this 0. Now obviously when these bits are shifted and placed like this, what about these 2 empty places? The right side empty places will be filled with zeros. And what about these 2 bits which are shifted out? They will be just shifted out and lost. So whatever those bits may be, ones or zeros, they are just shifted out and lost. Again I am telling, A remains as it is, so A is still 12, but C will get a new value which is this bit pattern. Now if you calculate this bit pattern, it is 16 and 32 is 1, so they will be added and C will hold the value as 48.